Okay, so domain and range, right? Familiar, hopefully, to us, but also maybe we'll remind ourselves of some things as well. So again, I'll just kind of redefine domain, and this is maybe not the most official mathematical kind of definition here, but we talk about domain, right? The domain of a function is all possible inputs, or in other words, sometimes x values, right, of a function. Okay, if a domain is not given, so like most of the time, right, you guys are given functions and you're never told what the domain of that function is, right? And that's because when you're given the domain of a function, when you're given a function and you're not told a specific domain, that basically means that you're supposed to assume that it's just all real numbers, or of course all real numbers that work. And so sometimes we got to look and see what are the things that would not work in our function. How do we know? Because again, talking about domain, right? I mean, how do we check all the possible inputs of a function? I mean, if you're talking about all the real numbers, that's you're literally going to sit there forever plugging in an infinite number of numbers to figure out which ones work when you plug them in and which ones don't work. And so rather than checking each individual one, right, we assume all of them work, and then we look for ones that don't work, right? And so those are domain restrictions. Domain restrictions. Okay. And for our purposes, we're going to be looking at two main types of domain restrictions. Okay, one of those being dividing by zero. Okay, obviously that's a big no-no in math, right? Not dividing by zero, and we'll talk about why, or at least if you're hopefully trying to develop an idea about why it's why dividing by zero causes so many problems for us. And then number two, the square root. And again, we always, I think, sometimes we get lazy, we just say square root, but really it's not just a square root, it's any even root. So like this includes fourth roots, sixth roots, eighth roots, 10th roots, of a negative. Okay. And again, the reason for that is when we square root of a negative number, or we fourth root or sixth root or eighth root or 10th root a negative number, we get an imaginary number, right? And so right now we're just keeping it real. In fact, I don't think we're going to hit. Yeah, we don't really deal too much with complex numbers or anything like that, okay? With I or imaginary numbers or anything. So we just want to keep it real for the most part in this class here. Okay, so with those two things, all right, let's jump in here and just look at a function. So let's ask the question, what is the domain of y equals 4x squared minus 3x minus 7? What is the domain of that? Of course, and so what is the domain of this? All real numbers, that's right, because, if you look here at our two domain restrictions that we have to look at, right, is it even possible to divide by 0? There's no division in here at all, right? There's no division here. So it can't be divided by 0. And then also, as far as square roots are concerned, there's no square roots. Any input is going to be squared and then multiplied by like a -3 there, or multiplied by 4 and then also multiplied by -3. So it's like there's no possibility. There's no domain restrictions there, and so we are all good, right? So now, how to describe that, right? So there's a variety of ways to describe the domain, and we really should be comfortable with like all of them, okay? With any way to describe the domain. So like one way to describe it is just using words. We can just say like all real numbers, okay? Or if you want to be like really fancy, okay, mathematicians use the symbol that for real numbers, okay? It's just a capital R with like two lines there instead of just one, okay? 2 lines like that instead of just the one. So we could just say all real numbers using words, right? We can use an interval, so that would be like negative infinity to infinity. Remember, when we write those intervals, that's so like words, that's words, right? We can use interval notation. Okay. Remember, intervals start from left to right on the number line, right? So you always want to start from your lower numbers, then and end at your higher numbers for that domain. Okay. And then we also have inequalities too. So you could say something like negative infinity less than x less than infinity as well. That's like inequality notation. Right. And there's also set notation, but we don't need to really worry about that. I'd say these are the three big ones you should really worry about. Set notation, I know it's in like Common Core. I mean, you saw it in like Algebra 2, I think. But nah. Set notation is almost the exact same thing as inequality notation, so why bother? Okay. And if the directions don't specify, you are free to answer in any three of those ways. Okay, so feel free to answer however you most feel comfortable. All right. Let's try another one. All right, f of x. Okay. Equals 1 over x plus 5. Okay. So, new situation, right? We have some division, and in fact, we could potentially divide by 0. So here, we could divide by 0. Okay. Right? Have a denominator. We have a variable in the denominator there. All right. And now, granted, this is obvious, right? I mean, what number is restricted from our domain here? What don't we want to include? Negative 5. Right. Exactly. But as a general kind of guideline, right? If you look at your denominator and you see some variables, but you're like not sure what variables would make your denominator, equal to 0. I mean, what you can do is just we set the denominator equal to 0. Right? We set that denominator equal to the number that we don't want to equal to see what number we don't want to include in our domain. Okay? So we set the denominator equal to 0 and solve for the variable. Okay? Which again, I know you don't need to do here, but just, just for the practice. Okay, so we're like x plus 5 equals 0, and so then we subtract 5 from both sides, you get x equals negative 5. Okay, so x equals negative 5, that is a domain restriction. Okay, and so again, we'll list the domain here in a bunch of different ways. You could do it in words. You could say all real numbers except x equals negative 5. That's one option. Okay, all real numbers except x equals negative 5. You could also use interval notation here. To do the interval notation, we just don't want to include negative 5. So we'll still start at negative infinity. We'll go up to that negative 5 on the number line, but we won't include it, right? The round parenthesis means we do not include it. And then we'll do a little union here, and we'll start back at that negative 5, and then we'll go up to positive infinity on the other side. So that's interval notation, right? So that's another way to do it. And then with inequalities, there's not necessarily, I don't know if there's another way to do this, but you could just say like, x is less than negative 5, or I should say, or x is greater than negative 5. Okay, something like that. I guess it wouldn't really be an inequality because there's no time when x is both. Yeah, it should be or. So for x value is less than negative 5, or x value is greater than negative 5. Okay, so 3 different options there depending on what you like. So, what is happening here, right, with that negative 5, right? Why does that negative 5 kind of cause us issues? Right? Well, if you go to your graphing calculator here, we can kind of like examine this a little bit more closely. Okay, it'll actually help us just because it's a little bit quicker and easier that way. All right. But if we type in 1 over x plus 5, oops, and make sure you put parentheses around the denominator like that. Okay. So if we go to our y equals and type in 1 over x plus 5. All right. And again, what I recommend you do for our purposes, if you press second window and go to your table setup, change your independent variable from auto to ask, because we want to type in some values here for x. I'll clear out my old values here. So obviously, if I go to my table here, and if I type in exactly -5, the number that makes our function undefined, I get an error, which is like no surprise there, right? Our calculator doesn't like to divide by 0. Okay, but what is happening? Why is that an issue? So let's pick a number that's kind of close to -5, right? Let's see what's happening maybe. So I'm going to pick like -4, for example. It's close to -5. Right? So if we evaluate f of -4, we get a 1 here. All right, so I'm going to write this maybe over here. Okay, so f of -4 is 1 over -4 plus 5. And man, this is hard to write with the way I've set myself up here. And so we get then 1. Okay, -4 plus 5 is 1. 1 over 1 gives us 1. Okay. So -4, that's pretty close to -5. Let's get even closer to -5. Let's do like -4.5. Right, -4.5 is even closer, so we'll type that one in. Okay, so that takes us to 2. Okay, so that's a 2 now. So f of -4.5 gives us, 1 over -4.5 plus 5, and that's going to equal 2, which again makes sense because -4.5 plus 5 is 0.5, which is 1/2. 1 over 1/2 is 2. Okay, but let's get even closer. So let's try like -4.9, which is really close. It's only 0.1 away, right? And now we're at 10. Okay, which again makes sense. So -4.9 plus 5, that gives us 10, which again makes sense, right? -4.9 plus 5 is 0.1 or 1/10. 1 over 1/10 is going to give us 10. And so, okay, I mean these are all working, and we're getting closer and closer to -5 here. So let's get even closer. So let's try like -4.999, right? That's really close to -5 now. And we get 1,000. Okay. And so we can keep going with this, right? We can do like -4.999999999, and you can see that. So that's how many, however many 9s you see there, and then if you arrow over, it's 1E9, which is the way your calculator does scientific notation kind of thing. So it's 1 times 10 to the 9th. So you can see it's 1 followed by that many zeros there, okay? And so that was, and that's even close. In fact, it's so close to -5, our calculator just says it's -5, when really it's not. It's using the -4.9. And if we keep going, lots and lots and lots of 9s, eventually our calculator just gives us an error, okay? And so what happens here, as our x values get closer and closer and closer to that -5, the function values get larger and larger and larger. And so as we get closer and closer to that -5, we're getting bigger and bigger and bigger and bigger values, and in fact we'll approach what? Infinity. Yeah. So as we continue here, we're going to eventually just approach infinity. This thing increases without bound, okay, as we get closer and closer to that -5, never actually getting to -5, right, because it would be undefined. But the closer we get to that -5, the more it increases without bound. And since there's no limit to infinity, right, it just keeps going, we have no value, right? There's no value there. And so it's just undefined, right, an undefined value. We don't have a definition for it because it just keeps going, right? Infinity keeps going without stop. And so that's why, right, we have that that idea of being undefined at -5. Okay. If you were to approach from the other side, all right, so if you were to approach -5 from the left-hand side of the number line, so like using like -5.1, -5.01, -5.0001, so on and so forth, you'd be approaching, I believe, negative infinity. And so then there's another problem too. From the right-hand side, you're approaching positive infinity. From the left-hand side, you're approaching negative infinity. And so the infinities don't even agree. All right, and so still another kind of like idea about why we just say the value at -5 is just undefined. All right, and again, that idea right there, what we just did, okay, is actually a calculus topic. This is a numeric approach of approximating a limit, and limits are like a calculus topic. We'll see more about limits later, but what we just did right there is like a kind of a calculus, an idea in calculus. Okay? Approaching a number as opposed to actually getting there and stuff like that. All right, let's look into one more here, and then I'll have you guys try some. All right. Sorry, so there's our next function, and I guess I just called it y equals there instead of the square root of x minus 4. I guess I should put it like f of x or something, but that's okay. Okay. So here for this function, could we divide by 0? No, there's no division, right? No division, okay? But we could take the square root of a negative, right? We have a square root, and we've got like the variable inside there, okay? So, since we could take the square root of a negative, I'm just going to use a symbol, okay, like that, square root of a negative there, okay? We must set what is under the radical, and it's called the radicand. What is under the radical to be, and then what? If we don't want to take the square root of a negative, what kind of inequality should we set up? Not negative. It means we want the value to be what? What's that? Positive or
greater than the absolute value of -4, 0.
yeah. So that's what the answer will be basically, I guess. Yeah, but 0, right? We were going to set it to be greater than or equal to 0, right? Because to not be negative, right? To guarantee something is not negative, it either has to be greater than 0 or equal to 0. And so that's what we'll do, okay? To be greater than, okay, or equal to 0. Okay? So that x minus 4, that's inside the square root there, we don't want it to be negative. So we'll just say, let's make it not negative. We'll just set it to be greater than or equal to 0. And so we get that x is greater than or equal to 4. Okay, and resultingly, there's one of your domain descriptions right there. There it is as an inequality. You can just describe it as an inequality x is greater than or equal to 4. If you want, you could write it as, the compound inequality. That would also work. Okay, or of course the interval where we would start at and include 4, right? That's the lowest value, and then go off to infinity. So there's all the different kind of options you could have. In words, I don't know, I would say something like, all real numbers x such that x is greater than or equal to 4. So really you just end up writing the same inequality. I can't think of another way to do it in words without, having to use the inequality over again. But there it would be in like words or something like that. Okay? So, questions on any of that? All right, let me give you guys one to try here. So, all right, this might be, well, we'll see here. I'll have you guys give it a try, and then we'll go over it. Okay, so 2x, square root of 2x plus 6 over 3x minus 7. I do all the easy ones, I give you a hard one, okay? That's how this works, right? And you can describe the domain in any way that you choose, any way you wish. And I'll kind of come around and help. got my own answers up here. Can't do math. Okay. Oh, yes. What you need to do here is, so the way you have this typed in, your calculator is going to do 1 divided by x, and then add 5 to 10.
Well, it would technically be between -3 and 30. Right.
Yeah, so that's right. So you got your yeah. So now you got to combine it into an interval then, right, or an inequality.
So it can be less than -3 and it
So
can be
those are right. Yeah. So Morgan, I would say start with what is the lowest possible value you can be, and then kind of work your way, to the right.
It can't be less than -3.
Yes.
So then I could put in like the bracket.
Don't forget that you also need to.
Yeah.
Bracket and also 7/3 and then 7/3 penalty. That would work for us another way, right?
Okay, very good. Yes. I would leave it at 7/3 if I were you to leave the fraction. So, well, you're not done yet. You still have some more information to look out for. Yes, right. So that needs to be what?
It can't be 7/3.
Yes. We want to be, well, we want that this to be greater than or equal to 0, right? Because we don't want to take the square root.
No, it can't, because that right there has to.
So don't forget, be careful here. This is not going to be negative, it'll be positive. You're going to add 7 over. That would be right for what you have.
I don't like it.
So, well, if I make it up, so,
Oh my God.
look at it. So,
I'm thinking about it.
no, you don't really have another side square. You have to give extra. You don't have like a value right now. So that's not working if we don't have anything to square up. But you look there, right? You want to think about what's the name or watch out. We don't want to divide by 0. What we could do here, right? This was equal to 0.
You end up getting the
Then
same
you put your value where we want. We're talking about 0. Take out less. And then also you could do the square root of a negative. This thing, this value, this thing here could be negative. Right? You want to again take this and set it to be greater than or equal to 0. And solve both of those things. Now that you can do a domain restriction. Is that clear? Pretty good. All right, let's start with the very first one. Dividing by 0. Right? So what thing here is going to determine whether we divide by 0?
Oh, where were you?
Right, so let's take that and set it equal to 0 and figure out what the exact x value. So you can see like those, not really, what we're doing is kind of like a side look. We're not really manipulating this at all, we're just like taking pieces out to help us analyze it. So the very first step, the side thing, you're just setting equal to 0. Minus 0. Right, yes. Actually, set up the equation. Set up an equation to solve it. That's all you gotta do. Just write out 3x minus 7 equals 0. Just solve. And you'll be able to solve for the value. Yeah. So that's one domain. So right now, your domain is negative infinity to 7
What's the reader? What does the slice screen look like? Okay, also have it right on the or is that gonna form out?
I put the,
Well, no, I mean like overall.
bracket -3. Because look at the, and then I did -3.
So that will then give you your domain restriction.
And then I did union and then
I'll show you here. Go ahead and choose. Write that greater than or equal to. Just somewhere, anywhere. There we go.
And that is
Okay, perfect. Now solve. Yep, that's perfect. Yep, okay, great. So that means you only want x values that are greater than or equal to -3. That means the lowest x value you can have in your domain is -3. Your x value can be greater than or equal to.
I forgot about that. That's what's good at reading.
So your domain, you prefer like, I guess let's use the interval. The lowest we can start is -3. Your interval will start at -3.
I'm pretty slow to read, but it's
But then you want to square bracket around that to be included, right?
So that
Yes. Okay, and then we just think about moving along the number line, the next column is 7/3. So we want to go comma 7/3. But we're going to exclude it, right? Because we can't think that we the parentheses. I get 89. And then you just want to, now you're going to start back in the second third. On the other side, and go up to the other, and those next values.
I thought I was because I had to.
Okay, does that make sense?
Maybe not.
Okay, so just, we put together both things on all
I know you have your time and stuff, but
Every day.
And we'll get some practice on this going. Yes, that's right. Here you don't need to say greater than equal to, you're just equal to here. So
Jonelle was not great.
okay, so now think about setting up your intervals here. What's the lowest possible x value you can start with in your domain? Right, so you want to start your domain at -3. And then can we include the -3 or we exclude it? Well, we can equal -3, right? So we can include it. Yep, okay, you can do that. And now we come across another problem now. We get rid of -3. We go up to 7/3. You want to do -3 less than 1x less than 7/3.
That's like when I
And then you also put 4. And now start back at 7/3.
she believes everything I'm doing.
So it's both this and this. We have to.
Only one I have.
All right, folks. Good. Okay. We want it to be greater than or equal to. All right, folks. Sorry about that. Here we go. Okay, I know that was a bit trickier, right? Because I just threw everything at you. I did two, nice easy ones, and then boom, there's suddenly make it difficult. Okay, but there it is. Okay, in this case, we can do both possibly. Okay, we could divide by 0. That would be when the 3x minus 7 is equal to 0. So we set equal to 0 and see that x equals 7/3 is the precise value where we will divide by 0. So we have to exclude that from our domain. But also we could take the square root of a negative. If 2x plus 6 is greater than or equal to 0, right? We want that. We want it to be greater than or equal to 0 so that we were not taking the square root of negative, and so we solve that to be x is greater than or equal to -3. Alright? So, any questions on just those two about how we found these two right here? And again, we'll get more practice with this, but any questions on just these two? Okay. And so then once you got those two pieces, now putting them together into our interval is tricky, but just, think about a number line, okay? We take our domain, which we start assuming it's the entire number line, but then we start taking out pieces that we are restricting, right? So for example, the lowest we can possibly go according to this, x must be greater than or equal to negative 3. So we're going to start at negative 3, including it because it's equal to there, right? Then we kind of move along our number line. The next problem we hit is at 7/3. We got to exclude 7/3. So we'll do 7/3 excluded, union 7/3 excluded, up to then infinity. Okay, and that includes all of our possible numbers there. All right. So we'll get more practice with that here too in a second though. Questions on any of that? All right. I'm going to look real quick here at range, and then we'll get started on our things here, okay, on the assignment. All right, just so you can have some more practice. All right, the range, it's all possible outputs or, in other words, y values, okay, of a function. Okay. And so this is a little bit tricky here because we don't really talk about like range restrictions, like y values that cannot exist and stuff like that. Instead here we kind of go with like two options. All right, option 1, if it's available to you, okay, is you can use your calculator. Okay, you can like, you know, and graph the function. You know, so I'll just do like a quick example of that. You know, I don't know. Let's just say, for example, we've got 2x or negative 2x squared plus 5x minus 7. Okay. Negative 2x squared plus 5x plus 7. So we can just, you know, go to our graphing calculators. Okay. Type this thing in. Before I graph it, though, we should at least have an idea about what this thing will look like. What is this going to be? What is this graph going to be? A parabola, right? And not only a parabola, we also know it's going to be an upside-down parabola, which means we would expect there to be some maximum value, right? If a parabola is upside down, that means you're going to have some maximum y value. So our range has an upper limit, right, a stopping point, but then our range will have no lower limit. So we already know that our range is going to go from negative infinity up to, and we just got to figure out what that highest value is. So we'll go to the graph here, and it doesn't even show up with my window, so hopefully it'll show up here. All right, there it is. So you can see again, there it is, just like we expected. Parabola, right, upside down because of that negative 2 in front of the x squared, and then we just have to figure out what this maximum value is. So what command should we use here in the calculate menu? Maximum, yeah, exactly right, maximum. Okay, go to the left, hit enter, go to the right, hit enter, and then for guess, the idea is to move the target cursor thing as close to the maximum as possible, but normally you don't need to do that. You can just hit enter a third time if you need to. And so there's our maximum. So the calculator gives us a weird decimal here, all right, at least for the x value, but we're not interested in the x value, we're interested in the y value. So we can just say negative 3.875, okay, and so the range here, and again I'm going to use an interval, but you can use, you know, inequalities and stuff like that. So it'll go from negative infinity up to that negative 3.875, which I think is 7/8, negative 3 and 7/8. Question? Oh, right. Sorry. Thank you. Yes, we do want to include that. Sorry, I was not being careful there. Yes, we do hit that maximum value. Yes, we do hit that maximum value. Okay. So that's option 1, using the, you know, calculator and just graphing it, and then, you know, finding what the highest point, what the lowest point is, and all that stuff. Option 2, and this is typically when you don't have a calculator. It's kind of like use, you know, what you know about the parent function, okay, and transformations. And that's why we talk about these things like parent functions and transformations, because it kind of expands our library of the different kinds, of our familiarity with the different kinds of functions that we run across. So, for example, let's say we want to evaluate the range of, x minus 7. Okay? What is the graph of y equals x minus 7 going to be? A line, okay? What's the range for a line? All real numbers, right? It's going to go up, it's going to go down, because especially because we have the slope of 1 there. We know it's going to go up one, right one, up one, right one, and down one, left one, down one, left one. And so it's going to hit all real numbers. So again, you know that because of your familiarity with lines, right? And so we can just say all real numbers or negative infinity to infinity. Okay? What about the range of like y equals the absolute value of x plus 4? Yeah, James?
Well, isn't the range going to be like at the lowest point it's going to be 4?
Correct.
It's going to go through infinity.
Right, and how do you know the lowest point is going to be 4? Doesn't the absolute value of x start at 0, 0? Like where do you get that 4 from?
Because it moves up 4.
Right. So the normal absolute value of x graph, which I'll just do a quick little sketch right here, right? It looks like this. And so the range would be 0, including 0 up to infinity. But because we're shifting everything up 4, that means our range is also going to shift up 4, and so it's going to start at 4 and go to infinity. Okay, like that. So that's what I'm talking about here, using those transformations to help you also identify the range without using like needing a graphing calculator, because of your familiarity with those different pieces. Okay? So that's that. Let me give you guys your assignment here, and we can get some extra practice in, because I think that'll be a good thing. All right. Yeah, we'll hold off on that. So actually, Abby, if you could please, there's a worksheet there. Yeah. Yep, that one. If you could just hand one out to everyone. Abby's going to come around and give you a worksheet, and there's a small book assignment too. If you want to just do it on the back, that's fine. Page 50 in the book, 71 to 81, the odds. And then also and the domain range worksheet.